For this question number 44, I was asked to convert the equation to standard form by completing the square, then identify what type of conic section it represents. And to start off for this equation, we need to group up the like terms. Then from there we need to factorize. Now we can take out, for the x side, we can take out -4 as the factor, and for the y side we can take out +9. Now we have to complete this square. So to complete this square, you need to take the coefficient of the x value, divide it by 2, and square it. And that will give you the square for this side, for the x value. Then for the y value, you do the same process. You take the coefficient in front of the y, you divide it by 2, then square it, which gives you 1. And then once you do this, you have to multiply said number by the factor that was extracted, and then add it to the other side, so that way the formula stays balanced. From there, you want to get rid of the value on the opposite side of the equal sign. You do this by dividing it on both sides. Then from here, this is where it simplifies the coefficients in front of the two squares. And this will give you your equation of your conics. In this problem, it's a hyperbola. Now, since we know that our answer is a hyperbola and this is the equation, we need to find the center, the vertices, the foci, and the asymptotes. Now the center is pretty obvious. You can find it by using the h and k values right inside of the brackets. For vertices, you implement the value a, which in this question is 2, into the graph to get your two vertices. For foci, we have to find the value of c. c is equal to root a squared plus b squared. Once we find c, we implement it into the formula of open bracket x k plus minus c. From here we have to find the asymptotes. Now to find the asymptotes, the formula is as shown here: y equals plus minus b over a times open bracket x minus h plus k. Now we have to replace these values, and we do so by implementing the b and a values respectively, as well as the h and k values. Once we do that, we solve, and we should get, for the two asymptotes, y1 equals to 2x minus 3 over 3 and 3 minus 2x over 3. And that should be the answer for the question.